Hello calculus class, this is going to be day 4. We're going to be solving equations and inequalities of polynomials and rationals. We're going to look at solving rational functions, equations that have fractions in it. And whenever you have a fraction bar, it implies that your numerator and denominator has parentheses around it. So what I want to do to solve these problems is get rid of the denominators. I don't want to work with these fractions, and I need to multiply every term by an least common denominator, or just a common denominator. It doesn't really matter. So for me, in this example, if I do everywhere I do a 5, and then what happens is that these 5 cancels and these 5 cancel, and I get the very simple x minus 2 plus x plus 3 equals 30. 2x plus 1 equals 29. 2x, oops, working ahead of myself. 2x plus 1 equals 30. 2x equals 29. X equals 29 over 2. Pretty easy problem. The next one, a little bit more difficult. X minus 1 is in parentheses. So my common denominator is 2. X minus 1, I have to do it once. I have to do it twice. I have to do it 3 times. So when I do it the first time, the x minus 1's cancel, and I get 2 times 3, which is 6, minus the 2's cancel, 5 parentheses x minus 1, and then negative 1 times 2 is negative 2, x minus 1. I'm going to distribute. I'm going to combine like terms. I bring this over, I get 3x. I bring this over, I get 9. And when I'm done, I get x equals 3. Now what I should do is check to make sure that it works. So if I plug 3 in here, I get 3 over 2 minus 5 over 2, which is negative 1, and it does work. Okay, the next examples. Again, it's just finding a common denominator. So for this next one, my common denominator, I just take my denominators and I multiply them together. So I get 12x once, twice, 3 times. And the first time I do it, 12x over 4 is 3x times 5 is 15x. 12x over 3x is 4 times 3 is 12, and this is 24x. 12 equals 9x, and I divide by 9, I get x equals 12 over 9, or 4 over 3. And this last one, all I have is an x. When I multiply x times x, I get x squared. These x's cancel out. I get plus 3x. And this is equal to, excuse me, I just get 3. And then I get 4x. I'm going to subtract the 4x over. And then I'm going to factor. X minus 1, x minus 3. And I get 2 solutions. If I go back to the original problem, you'll see that they both work. Plug in 1, I get 1 plus 3 equals 4, and I plug 3 in here, I get 3 plus 1 is equal to 4. Sometimes I get 2 solutions. So for these next problems, I have to make sure I don't have extraneous solutions. An extraneous solution is a false solution. That means you did everything right algebraically, but it does not work in the original problem. So at the beginning of this problem, I noticed that because of these denominators, x cannot equal 1 or 3. If I factor this, it is just really the 2 other denominators. Okay, if I use 1 or 3, I'm dividing by 0 in this problem, and that cannot happen. So if I get 1 or 3 as a solution, that means I probably did everything right algebraically because I had to manipulate it, but it cannot work in the original problem. So when I look at this problem, I'm going to multiply every term by, let me pick something. This is the common denominator, right? This is in parentheses. So x minus 1, x minus 3, x minus 1, x minus 3, and a third time, because I had to do it every term, and I notice that x minus 1 cancels out, and I'm left over with a 2x and x minus 3. Plus, now the x minus 3's cancel, I have 1 times x minus 3, and now both of these cancel. I just have a 2 here. I'm going to clean things up a little bit. I'm going to bring the 2 over, combine like terms. Wow, made a mistake here. This is 1. This is 1. The x minus 3 cancel out. It's that x minus 1 left over. My bad. So factor 2. I get this. 2x squared minus 5x minus 3. Factor it. 2x and x. A 3 here. I'm going to do a minus 3 here. I'm going to go plus 1 here. Let's see what I get. 2x times x is 2x squared. 1 times negative 3 is negative 3. Those are good. These guys on the outside makes minus 6x. These guys on the inside make positive 1x. Minus 6x plus 1x is my negative 5x. Now when I solve this, I get x equals negative 1/2. I get x equals 3. This is a solution because at the beginning we said this was extraneous. Okay, that's what you have to watch for. So for the next problem, when I do this, I notice that x cannot equal 0 or negative 2, because this one over here is just the two denominators multiplying each other. So I'm going to multiply through by x plus 2, x plus 2, x plus 2. And even the other side I have to do it, but it's just 0, so I'm not going to write it down. It's not really necessary. So when I multiply this out, the x's cancel. All parentheses around this. X minus 3 times x plus 2. X plus 2 cancels out. Plus 3x. These cancel out both. Plus 6 is equal to times 0 is 0. I FOIL this out. I get x squared plus 2x minus 3x minus 6 plus 3x plus 6 is equal to 0. I combine some like terms. I get x squared plus 2x is equal to 0. I see something in common, so I factor out an x. And I get two solutions. X equals 0 and x equals negative 2. And I realize they're both extra. So there's really no solution to this problem. Okay, that could happen. Okay, so these next ones are going to be inequalities. And I'm going to set it up where, well, I have to have it factored first. I need to know x-intercepts. I need to know what I'm looking for. I need to know the leading term. I'm going to make a number line and put a sign chart on it. So right now, this is already factored. So I have x equals negative 1/2, 2, and 4/3. So I'm going to make a number line, and I just have to put these in order. I don't care the spacing. Negative 1/2, 4/3, and 2. And if you want, these are the zeros. I'm going to put little zeros above them. These are the x-intercepts or the zeros. And if I need to do my leading term for this problem would be 2x times 3x, which is 6x to the third. Okay, let's go back to our graphs. When we did graphing of these polynomials, we said 6x to the third meant something to us as a leading term. First, it meant the right side of the graph went up because of the 6. So on the right side of this number line, this is going to be positive. And then every time I come to 0, it's going to alternate. It's going to go back and forth, unless something special happens, and we'll talk about that next. So after this, it goes positive on the right, it hits a 0, it goes through it, it goes negative, hits a 0, goes back positive, hits a 0, goes back negative. So if I read it left to right, the graph goes below the x-axis, x-intercept, above the x-axis, x-intercept, below the x-axis, x-intercept, and above the x-axis going up to infinity. Okay? And the idea is that x to the third means the two ends better be opposite. And look at these two ends here. These ends are opposite. If I wanted to draw a graph, a two-dimensional graph of this graph would look something like this. This number line is the x-axis. This is what the graph would look like. But I don't need to draw that two-dimensional graph to figure this out. Now I do have to pay attention to what I wanted. And what did I want here? This says less than 0. That means I want it where it's negative. I want to know when my results are negative. So the numbers in blue are the x values, and the things in red, the plus or minus signs in red, are what the y values are at that point. So to me, I want when things are negative, I want this guy, I want this guy. If I write my result in interval notation, negative infinity to negative 1/2, union 4/3 to 2. If I take any number in this window and plug it in this function, it would be a negative result, and the same thing over here. Okay, the next one, it's a little bit different because look at what we have here. So my x-intercepts are negative 1, 3, and negative 4, but this one is special. This one is a bounce. So when I make my number line, I'm going to note that. Like I said, I don't care how big you make your number line. I don't care the spacing. Just put these numbers in order. Negative 4, negative 1, 3. These are the zeros, the x-intercepts. And I'm going to note that at 3 I have a bounce. Now when I do my leading term, I get x times x squared times x. So I get 1 x to the 4th. That 1 means something. That means the right side is positive. A bounce means I have a positive y, hits the x-axis, and bounces back to a positive y. So anytime I hit a 0, I'm going to alternate unless I see I have a bounce there, and a bounce means on both sides of the bounce I have to have the same sign. In this case, it's positive. This 0 means I go negative, and this 0 I go back positive. X to the 4th is an even function. That means both ends better be the same. And if you notice, x to the 4th, these ends are the same. If I wanted to draw this graph, I could draw this graph. It would go above the x-axis, below the x-axis, above the x-axis, hit the x-axis, and bounce off the x-axis. That's what the graph would look like two-dimensionally, but I don't need to draw it. Now I have to pay attention to what I want. And what do I want? I want wherever these results are positive and equal to 0. So the equal to 0 part means I'm probably going to use brackets, not parentheses. So my positive results are here. So I would write it out as negative infinity to negative 4 bracket, and I have to include that 0. And then I would maybe do something like this. Negative 1 to 3, union 3 to infinity. But it doesn't really make sense. These are connected together with brackets, so I can kind of get rid of all this and just do -1 to infinity. And that would make anywhere on this interval, any number I would pick here, I would get a positive result over 0. So for the next problem, I first have to factor the polynomial. I cannot do this number line business unless it's factored. And I took out an x because I saw everyone had an x, and then I factored out the rest of the problem. And my x-intercepts for this are going to be, well, the first one's 0, the next one is 3 over 2, and the last one is 1. And there should be 3 x-intercepts because it's an x cubed problem. It's even nice, so I'm going to make my number line. Like I said, I don't care about the spacing, just as long as you have them in order. These are my zeros or my x-intercepts. What's nice is that my leading term is given to me, 2x cubed. Oh, 2 is a positive. There's no bouncers here, so I'm always going to alternate positive, negative, positive, negative. X to the third, the two ends better be opposite. Now what do I want? Less than 0, I want the negatives. Negative here, negative here. Okay, this next one, I gotta factor it. Oh, I can't take an x out. So I better do synthetic division. My p's over q's, I'm going to erase that. I'm going to draw a different color. My p's over q is going to be the factors of 6. 1, 2, 3, 6. And then my factors of 1, because there's a 1 up here. Well, what should I try first? I'm going to try 2 first. I'm going to stay away from the 6. I'm going to try 2. My coefficients. I draw my line. I bring down the 1. I get 2. I get -2. I get. So 2 is a factor. So after that, I have to decide what I want to use, and I'm going to guess 3. Kind of because I know what I'm doing. Bring down the 1. I get 3. I get 1. I get 3. I get 0. So when I factor this 2 means these numbers mean I had x minus 2, and then I had x minus 3, and at the end here, so this was x cubed, this last one is really x plus 1. So when I factor it, I have x minus 2, x minus 3, x plus 1. I want less than or equal to 0. My x-intercepts are obviously 2, 3, and the last one was -1. My leading term was given at the beginning of the problem, 1x cubed. I want all the negatives or equal to 0. So here's my number line. Like I said, I don't care about the spacing. These are zeros. Oh, no bouncers, positive, negative, positive, negative. I want the negatives and or including the 0, so I get a -50, -1 bracket union 2 to 3. So these problems that with the rational functions with inequalities are very similar to what we did with the polynomials. We have to factor. If it's not factored, we set up a number line, we have a leading term, and we decide if we need positive or negative. I only had to factor the denominator, So my numerator are the x-intercepts, and that's -3. My denominator are the VAs, and that's -4 and 4. And my leading term on top would be x over x squared, which is 1 over x. Okay, so I'm going to set up a number line. Like I said, I don't care about the spacing. -4, -3, and 4. -3 is a 0. But -4 and 4 are VAs. My leading term is 1. This is a positive 1. And it's actually 1, x to the -1. So this is a positive 1, it's positive. And every time I come to a feature, I'm going to alternate unless I have a bouncer. It goes positive, negative, positive, negative. Again, -1, or this 1 here is an odd exponent. So I better have opposite on the ends. And then what do I want? I want the positive results. The positive results. -4, -3, union 4 to infinity. Okay, I set up most of this next problem. I factored it. I have my numerator, I have my denominator, so I have my x-intercepts and my VA. My leading term over leading term is x squared over x squared, which is just 1. I had x squared over x squared, which is just 1, which is really 1x to the 0. 1 is a positive 1, so it's positive, and every time I come to a feature, which is an x-intercept or a vertical asymptote, I alternate unless there's a bouncer. I don't see any bouncers in this. So I get all that. X to the 0 is an even number, so the ends better be the same, and they are. And then my point is, well, what am I looking for? I want the positive or equal to 0. So the positives are here or equal to 0. Well, an asymptote is never equal to 0, so that's never going to, it's always going to be a parentheses on an asymptote, but these x-intercepts I'm going to have brackets on. So -infinity to -4, parentheses, union, got ahead of myself, bracket -2 to 2, and then 3 to infinity because that's an asymptote. Okay, thank you for watching my video. Ask questions in class.